So far in this series we have discussed about first normal form and second normal form, right? How to find out that a particular relation is in first normal form, a particular given relation is in second normal form or not, right? All the rules of first NF and all the rules of second NF, right? Now still we have some drawback in second normal form. So why we need third normal form? Because of those drawbacks. Now I'll tell you in this video that what are the drawbacks in second normal form, and that drawbacks we will remove in third normal form, and how to remove those drawbacks, right? First is obviously redundancy. First of all, we have redundancy in the table, then we remove the redundancy by first normal form, then again we do second normal form to remove the redundancy, right? Still we have some redundancy if table or relation is in second normal form, and because of that redundancy some anomalies may exist, right? Now what kind of anomaly can be there in second normal form, right? First of all we will discuss that thing. After that we will discuss with the help of that relation, that a particular relation is given, functional dependencies are given, then how to find out that this relation is in third normal form or not, right? Now see, suppose I am taking this relation or this table, student having these attributes of a student, and only primary key is what? Student ID, right? I am considering here that you can say only one candidate key, that is SID, so that would be primary key, right? Student ID, no more candidate key is there. Now here see, this is in second normal form, this relation is in second normal form. Now how can you say that? Because I haven't given any functional dependency, right? And in the previous video I have checked using that functional dependency, right? In the previous video I have told you one more important point about second NF is that if the candidate key, right, is having only one attribute, although luckily we have only one candidate key, suppose 3 candidate keys are there and all 3 candidate keys are having only one attribute. See, candidate key is also having one attribute. If candidate key is having one attribute, then that is, you can say, simple candidate key. If it is having more than one attribute, 2, 3, 4, then that is known as composite key, right? I hope you got now what is composite key. Now see, if the candidate key is having only one attribute, then definitely that relation would be in second normal form. Now why so? Because in second normal form there should be no partial dependency, right? And obviously it is in first normal form, it should be in first NF, and now by default we consider that given relational table would be in first NF. So and by looking at this table also you can see this is in first NF. Now partial dependency is what? If proper subset of candidate key determines known prime attribute, then only that is partial dependency, right? This condition is only of partial dependency. This is the case here, proper subset of candidate key, this side known prime attribute, right? It's not like that it is proper subset of candidate key and here we have prime attribute, then also partial dependency. No, left side should be proper subset of candidate key, right side must be known prime attribute, then only it is known as partial dependency. Now if only one attribute is there, then obviously no proper subset is possible of this candidate key. If no proper subset is possible, then we will never get this kind of partial dependency here. So this is in second NF, right? But still, what can be the problem in this table? If your database is in second normal form, that is also not considered as a good database. Why so? Because see here, what you can say here, the functional dependency is, see, using pin code I can determine state and country, right? So this is the functional dependency present here. And how to check that a particular functional dependency is valid or not, that also we have discussed in the previous video. You can check out that video in the side button, right? Now, so and pin code, and the pin code is not any key here, not candidate key here, right? It's, if not candidate key, then it is known prime attribute, right? State and country are also known prime attributes. Known prime attributes are those which are not a part of any candidate key. So here the prime attribute is only SID because it is only the part of candidate key, right? Now see, if you want to change the pin code here, right, it means what you need to do, Here also you need to change the pin code. Here also you need to change the pin code. And suppose because of pin code you need to change the state also. So here also you need to state change, here also change, here also change, right? I am taking a small table in which I am having only 3 rows where we have state is Haryana, and I am only changing the pin code of these 3 tuples. So in all the 3 tuples you need to change the state as well. Suppose this situation is in 500 rows. So in all the 500 rows you need to update this change, right? This is what a redundancy, na? Here you can see this is what redundancy, right? So here you can have update anomalies. We have already discussed what are 3 anomalies: insert, update and delete in the one of the previous video, right? I'll provide you the link of the complete playlist of DBMS in the description box. You can check out all the previous videos, right? So because of this redundancy we have update anomaly here. Although the table is in second NF, still there are some redundancy, still we have update anomaly if table is in second NF. So to remove this one, what you can do, you can divide this table, right, in 2 tables. Another table you can make which contains state, country and pin code, like this. This is the second table. I have taken this dependency, right, and I have decomposed this table into 2 parts. One table will contain SID, SNAME, DOB, pin code and total credit, not state and country. Another table will contain state, country and pin code, right? So now if you will change the pin code here at the 3 place, you need not to change that state at the 3 place, right? Only you can change here one at 1 tuple, and here only you can change the state, right? So now here we have removed this redundancy, redundant data. Although in one column obviously we have this pin code, we have to link these tables using foreign key, that also we'll discuss later. I'm just giving you a overview here. So now we have removed the update anomaly. Now why this problem comes? See, now this is very important point. Why this problem comes? Obviously because of redundancy, but because of redundancy, what functional dependency is there? Because of that the problem occurs. Because of this functional dependency. Because here pin code is determining state and country, and pin code is known prime attribute. State and country also known prime attribute. Known prime attribute is determining known prime attribute, right? So this functional dependency, this type of functional dependency caused the problem here. You have to remove that, and this functional dependency is known as transitive dependency, right? If transitive dependency is there in the table, then that table is not in third normal form. So now how can you say that a relation is in third normal form if and only if first one, it is in second normal form, that is for sure. Second point is it does not contain any transitive dependency, right? 2 points are there. Let me write. So these are 2 conditions for a relation to be in third normal form. First one, it should be in second normal form. You can say a relation is in third normal form if and only if first one, it is in second normal form. Second one is there is no transitive dependency, or specifically you can say there is no transitive dependency for known prime attributes, right? Now what is transitive dependency? See, if in a relation we have A determines B and B determines C, right? So this is transitive dependency, because if this and this is given, you can say that A will determine C. This is what, obviously you know this is transitive dependency, right? Now here A is also known prime attribute and C is also known prime attribute. If this is a case, then only you can say that in the relation we have transitive dependency present. So here how can you write it? If obviously they'll ask you in GATE or NET, so they'll give you one relation and set of functional dependencies. So if in that set of functional dependency you find out a dependency something like this, a known prime attribute determining a known prime attribute, then this is transitive dependency. It means that relation is not in third normal form. You have to check this only. Both side, left hand side and right hand side, both side must be known prime attribute. If any one is prime attribute, then there would be problem. See, if this side is prime attribute and this side we have non-prime attribute, then this will create a problem for second normal form, because this is what a partial dependency. If this side is a part of candidate key, right, subset of candidate key, and this side we have non-prime attribute, then this has partial dependency. If this is the case, then that would not be in second normal form, right? So obviously if not second normal form, then that is not in third normal form. So now here, suppose here we have candidate key and here we have non-prime attribute, then there would be no problem. This is not you can say a transitive dependency. And here suppose maybe you can get like this, here we have a non-prime attribute and it is determining a prime attribute, maybe sometimes, then this is also not transitive dependency. For transitive dependency, you must check both side must be non-prime attributes, that's it, right? Now let us take one example. Now let us consider this example. Now before that, see, you can also write down like this. Our table is in third normal form if and only if for each of its functional dependencies, right? And these functional dependencies should be non-trivial for each of its non-trivial functional dependency. If any functional dependency is given something like this, A, B determines A, right? Then we will not consider this case. For each non-trivial functional dependency, at least one of the following conditions hold. See, there are two conditions, but at least one condition. It's not compulsory that these two conditions must be hold in this functional dependency, at least one. Either left hand side is super key, left hand side means this one, right, that determinant, or right hand side is prime attribute, means the dependent is prime attribute. At least one of these conditions hold. You can write down something like this, or you can write down something like this. For this, obviously for finding the non-prime attribute, or you can say for finding the super key or the prime attributes, you must need to find out the candidate key. That is very important point. That also we have discussed in one of the previous video, right? How to find out candidate key. See, ABCD closure, you can take all the attribute first of all, definitely it will find out all the attributes. So you can say that ABCD is super key. Now find out candidate key, try to discard the elements, the attributes here. See, A is determining B, so you can discard B. A is determining B, B will determine C, so A will determine C, so you can discard C because we have A. C will determine D, so by transitivity property A will determine D, we have A, so you can discard D, so we have only A. So A is what? Super key. You can check if the attribute closure of A is having all the attributes of the relation, then definitely it is a super key. You can check. A will determine itself, right, by reflexivity property. A will determine B, we have A, so I can determine B, using B I can determine C, using C I can determine D. So all the attributes are there in the attribute closure of A. So A is what? Super key. Now is A candidate key? Definitely A would be candidate key. Why so? Because no proper subset is possible of A. A is only having only single attribute, right? So this is what? Candidate key. Now we have got one candidate key. So means prime attributes we have got, that is one, that is A. Now check out more candidate keys are possible here or not in this relation. How to check out this thing? If the prime attribute is present at the right hand side of the functional dependencies, then definitely there would be more candidate keys and you have to find those out, right? But here check, A's prime attribute, is A present on the right hand side? No, no, no. So now there is no more candidate key. Now we have only one candidate key, that is A in this relation, right? And this is prime attribute. Now you can check this condition, this kind of dependency present here or not. If yes, then this relation is not in third normal form, right? Check out. Check the first dependency. A, is A non-prime attribute? No, it is prime attribute. So this is what? This is not, we can say that this is a transitive dependency. No, right? So this is not a transitive dependency. Now check out this one, B. Yes, it is non-prime attribute, but only checking B, you can't say that this is transitive dependency. You have to check the right hand side also, because there also there should be non-prime attribute. C is also non-prime attribute. So this is transitive dependency. C is non-prime attribute, D is non-prime attribute. So this is also transitive dependency. So two transitive dependencies are there. So this relation is not in third normal form, right? This is in second normal form because by default I have taken these type of functional dependencies so that this is in second NF. You can check out this also, because if candidate key is having only one attribute, then definitely that relation would be in second normal form. So this is also in second and not in third but only in second NF. Or here if you will not check like this, so you can check like this, check these two conditions. First one is left hand side is at least one condition must hold for each non-trivial functional dependency. See, these are non-trivial functional dependencies, right? Trivial, I guess you know that if x determine y, then y is what? Subset of x. This is what trivial functional dependency, right? Now, see, left hand side is super key. Check out for this one, left hand side is super key. Yes, right? No need to check the right hand side. Only one condition, at least one condition must hold for the relation to be in third normal form. So check out for second functional dependency. Left hand side, is it super key? No, B is not super key. Now check for right hand side. Right hand side is prime attribute? No. So neither this nor this one is present in this for this functional dependency. So this is transitive dependency. This is also, because left hand side check, it is super key. Is it super key? No. So now right hand side is D prime attribute, is a prime attribute? No. So neither this nor this one is holding here, right? Now it is also transitive dependency. See here why I am saying that C is not a super key. Obviously if you find out the C closure, then what it contains, it will determine C itself by reflexivity property, and using the functional dependency C can determine D, nothing else. So attribute closure is containing only C, D, not all the attributes. So C cannot be a super key, right? Now let's take a different type of example. So let us take this example here. We have A, B, C, D, E, F attributes and these two functional dependencies are given, right? Now first of all, obviously find out the candidate key here. Now candidate key is, this closure would contain all the attributes, so this is definitely a super key. Now try to discard the attributes from here. See the functional dependency, AB is determining C, D, E, F, right? So we have AB, so using AB I can determine C, D, E, F, so I can discard from here, right? Can I discard anything else? B, D is determining F, but we have only B, we don't have D, right? So obviously we cannot discard now anything. So now AB, you can find out AB closure would also contain all the attributes. So this is what? A super key. Now find out it is a candidate key or not. How to find out? Proper subset would be A and B. Check out these are super key or not. A closure and B closure. A closure will determine itself A, nothing else, because here both AB is determining C, D, E, F, but we have only A, not B, right? So this is not a super key. Now B closure will determine B, only B, so this is also not a super key. So you can say that AB is candidate key, right? Now we go to one candidate key, that is AB, and prime attributes are here A, B. Now check more candidate keys are there or not. How to check prime attributes? Check out the prime attributes are available on the right hand side or not. Is A available on the right hand side? No. Is B available on the right hand side? No. It means there is only one candidate key, no more candidate keys are present in this relation, right? And prime attributes are A and B, non-prime attributes are C, D, E, F, right? Now check out for this dependency, is this type of dependency present here or not? See, first of all this thing, is this AB is non-prime attribute? No, AB are prime attribute. So this is what? Not a transitive dependency, right? No need to check the right hand side, because if this side is not NPA, so no need to check for this side. Now check for this dependency, see B and D. Now here see this point, you need to clear out this point very carefully. Both B and D, is this non-prime attribute? Now we will say that B is prime attribute, right? But D is not a prime attribute, so this we will consider as non-prime attribute. And right hand side is F. F is what? It's a non-prime attribute. So here also non-prime attribute, here also non-prime attribute. So this is violating the condition. So this relation is not in third normal form, right? I hope you got. Now if you you'll find the mix of prime and non-prime attribute, then you will consider it what? A non-prime attribute, complete, because BD complete is not prime attribute, D is not in prime attribute, so we'll consider it as non-prime attribute, right? So this is not in third normal form. Suppose I am going to modify it a little bit. Suppose I am having a more functional dependency, that is A determine D. So now check for this one also. Suppose I am taking this one also. So for this functional dependency, left hand side is non-prime attribute. No, it is what? Prime attribute. A is what? Prime attribute, right? So no need to check the right hand side. This is not violating that property. This is what we cannot say that this is a transitive dependency, right? Here only which dependency is violating the condition? Because of this dependency, this relation is not in third normal form, not because of this dependency, right? Make this thing very clear that both sides should be non-prime attribute, non-prime attribute, and this A is prime attribute, so no need to check this one. Or you can check this one, left hand side is super key. Yes, A is super key, so no need to check the right hand side, right? So now see, if this is a case, then check for the second normal form here, because this relation is now not in second normal form, right? See, A is determining D. A is what? Candidate key is AB, or you can say primary key is also AB, and a proper subset of candidate key is A, and this is determining a non-prime attribute. D is what? A non-prime attribute. So this is a case of partial dependency. Here this is partial dependency. So if this is a case, then this relation is not in second normal form, so definitely it cannot be in third normal form, right? Now here obviously I am not taking this one. Now check, this is partial dependency or not. See, BD, is it a proper subset of candidate key? Candidate key is AB. Proper subset of candidate key, one is A, one is B. Although we have B here, but we have D also. This complete should be a proper subset of candidate key. So this is not a proper subset of candidate key, right? So this is not a partial dependency, right? So this is in second normal form, but not in third normal form, because this is transitive dependency. I hope now you got all the points about this. So now how you can say that third NF is better than second NF? In 2NF we have one anomaly, that is update anomaly, because of some redundancy there, right? That is drawback. So now third NF will remove all the anomalies, insert, delete as well as update anomaly. So now you can say that that is why we say that this third normal form is adequate normal form for your database. Means if your database is in third NF, then you can say that it is a good database design. Although we have more normal forms are there, BCNF, 4th, 5th, DKNF, that also we'll discuss one by one later. Now I hope you got what is third normal form and how to find out that particular relation is in third NF or not. Now this is question for you. This is the relation, these are functional dependencies, and you need to check out is this relation is in second normal form as well as in third normal form or not, right? You need to tell me. Fine. Now if you want me to discuss more questions on these normal form, you can mail me your questions on my mail ID, or you can just tell me in the comment box. I'll discuss some more questions also. So now how to convert a given relation into third NF, third normal form, that thing we will discuss later after discussing the decomposition process, means lossless and lossy decomposition, right? In the next video I'll discuss what is BCNF, and after that I'll discuss about decomposition process. So now I'll see you in the next video. Till then, bye bye, take care.